In the last question we looked at some things that either were or were not probability distributions. The last one was. In the next question, we're going to be constructing our own probability distribution. So, this is number 8. A player picks one card from a deck of cards. If the player selects an ace, the player wins $20. If the player selects a face card, the player wins $5. And if the player selects any other card, the player wins nothing. So the first thing we're going to do here is construct a probability distribution for the amount the player could win. So a probability distribution has two parts to it. We're going to list all the possible values of our random variable, that is, all the possible amounts the player could win. So the player could win $20, the player could win $5, or the player could win $0. And now we have to put the probability with each one. So the probability of winning $20 is the probability of selecting an ace, because that's what would have to happen to win the $20. Now, I probably wouldn't put this exact question on a test because you have to know what's in a deck of cards, and some people know that real well and some people don't, but I wouldn't put this on a test without giving you that information. But I'm going to give you the information now. The probability of selecting an ace would be 4 out of 52, because there are 52 cards in the deck, and 4 out of those 52 cards are aces. There's the ace of spades, the ace of hearts, the ace of diamonds, and the ace of clubs. In lowest terms, that would be 1/13. 1 out of every 13 cards is an ace. So the probability of picking an ace is 1/13. The probability of selecting a face card, that would be either a jack, queen, or king of spades, hearts, diamonds, or clubs, would be 12 out of 52, or in lowest terms, 3 out of 13. And then the probability of anything else would be 9/13. And just to check, each probability is between 0 and 1, and when we add them together, 1/13 plus 3/13, that's 4/13, plus 9/13 adds up to 13/13. Now that we've got our probability distribution all set up, we can use it to answer this question. What is the expectation or expected value for this game? So that's where we take each amount we could win times the probability that goes with it and add those together. So we would take $20 times 1/13 plus $5 times 3/13 plus $0 times 9/13 equals 2.69. Now, I haven't been showing you these calculations like on a calculator. I hope you know how to take something like this and put it into a calculator and have it give you the right answer. But try this. Make sure that you actually do get 2.69 when you put this into a calculator. Actually, I've rounded that to 2 places after the decimal point because it represents money. But now part C says, if you have to pay $2.50 to play the game, would you win or lose money in the long run? And on the average, how much would you win or lose each time you play the game? So think about what this is saying. On the average, we're winning $2.69 per time we play the game. So if you gain an average of $2.69, but then you pay or lose $2.50, are you going to come out ahead or are you going to come out in the hole? Well, you are going to come out ahead. A gain of $2.69 minus a loss or payment of $2.50 equals a positive winning or profit of $0.19. That is 19 cents. So in the long run, if you played this game over and over and over, or if you had a whole bunch of people play it, the average result of all of those games would be winning 19 cents per game. If this had come out negative, or if the amount you pay was bigger than the amount you win back, then you would be losing in the long run. Okay, number 9. For the probability distribution shown here, find the mean, variance, and standard deviation. So how do you do something like that? How do you take a probability distribution and calculate the mean and the variance and the standard deviation? If you look up the formula in the book or on the important formulas card, it looks like this, which might or might not help you. You have to know what these symbols mean. But this is telling us that to find the mean, we have to find the sum, that is, we add together x times p of x. So we have to take each one of these numbers times the probability that goes with it and add those up together. So we take 0 times 0.10 plus 1 times 0.23 plus 2 times 0.31 plus 3 times 0.27 plus 4 times 0.09. And that should come out to be 2.02. Now the variance is the sum of x squared times p of x minus mu squared. So remember what that is telling us to do. We have to take each number on top, each x, and square it, and then multiply that by the probability, add those up together, and then at the end, subtract the mean squared. So here that would be 0 squared times 0.10 plus 1 squared times 0.23 plus 2 squared times 0.31 plus 3 squared times 0.27 plus 4 squared times 0.09 minus 2.02 squared. So that comes out to be 1.2596. You can either leave it like that or round it. But now for the standard deviation, we just take the square root of what we just did. So the square root of 1.2596 comes out to be, and this I did round to about 1.12. Number 10, use the formula for binomial probability or your calculator to find the probability of getting x equals 3 successes out of n equals 5 trials if the probability of success is p equals 0.65 on each trial. Now, the reason I said to use the formula or your calculator is because if you try to use that table B, it's not going to work for this one because it doesn't have 0.65 as one of the choices for P. So one choice is to use the special built-in calculator function on something like a TI-83 or TI-84. It's Binom PDF. So you would select that and you would give it the numbers for N and P and X in that order. And if you're not sure about the order, it's alphabetical. First N, then P, and then X. So we give it first the number 5, then the number 0.65, and then the number 3, and it gives us the answer 0.336 approximately. Or we could use this formula in NCRX times p to the x power times q to the n minus x power. So here the n would be 5, the x would be 3, the p would be 0.65, and what about the q? Well, remember q is always 1 minus whatever p is. So 1 minus 0.65 would be 0.35. And then here where it's n minus x, 5 minus 3 would be 2. So I just went ahead and put 2 there. So this is 5 NCR3 times 0.65 to the 3 power times 0.35 to the 2 power. So on the calculator, that's 5 NCR3 times 0.65 to the 3 power times 0.35 to the 2 power. And it does come out to be 0.336. If you have some other kind of calculator or app or something or other that you want to use instead, that's fine. Number 11, each applicant to a training program has a 40% chance of being accepted. What is the probability that if 11 people apply, exactly 5 of them will be accepted? So you should recognize that this is the kind of question that's asking for the probability of something happening 5 times out of 11 times that it could happen. That's a binomial probability question. So the n is the bigger of the two whole numbers. Here, 11. That's the number of trials or the number of times that something could happen. And then the smaller whole number, 5, is the x. That's how many times it actually does happen in the situation we're talking about. And then the p is the probability of it happening each time. So here, that would be 40%, or 0.40, or just 0.4. So with n being 11, p being 0.4, and x being 5, we need to find the probability, and we can do it either one of the ways we did in the last example with the calculator function or the formula, or this one we could look up on table B. And however you do it, the answer is 0.221. Number 12. A toothpaste company finds that the probability that a customer will mail in a rebate coupon on a box of toothpaste is 0.39. In a group of 5,000 customers, find the mean, the variance, and the standard deviation for the number of customers who will mail in a rebate coupon. So we've got 5,000 customers, so 5,000 individual times when somebody could mail in a rebate coupon, and each one of those has a 0.39 probability that they actually will. So this is like a binomial probability kind of situation. We got 5,000 trials, so n is 5,000, and we got a 0.39 probability on each trial that what we're talking about actually does happen. So p would be 0.39. And then for a binomial distribution, the mean would just be n times p. We would just multiply those two numbers together. So 5,000 times 0.39 is 1,950. If there's a 39% chance of somebody mailing in the rebate, then you'd expect around 39% out of the 5,000. 39% of 5,000 is 1,950. So that's the average number out of 5,000 who would mail in the coupon. The variance is n times p times q. So that would be 5,000 times 0.39 times 0.61. And where did I get that 0.61 from? Remember, q is always 1 minus whatever p is. So 1 minus 0.39 is 0.61. Anyway, that gives us 1,189.5 for the variance. And then the standard deviation would be the square root of that. So the square root of what we got for n times p times q turns out to be about 34.5. So that's it for the review problems. Hope that helped, and good luck on the test.